Hi, so in this video discuss LeetCode problem 840 magic squares in grid. So a 3x3 magic square is a 3x3 grid filled with distinct number from 1 to 9 such that each row, column and both diagonals all have the same sum. Given a row cross column grid of integers, how many 3x3 contiguous magic square subgrids are there? We have to find out, right? So the given matrix can contain numbers from 1 to 15, sorry 0 to 15, right? And I have to find a number of magic squares are there of size 3 cross 3, right? Where each row sum, like if it is a magic square, suppose this is a magic square, so this is still row sum, row 2, row 1, row 2, row 3. Here actually column 1, column 2, column 3, right? And this is one diagonal and there is two diagonal, right? So suppose this is diagonal 1 and this is diagonal 2. They are actually saying that diagonal sum should be same. Also D1 will be diagonal sum of suppose any diagonal, because already two diagonals same, and with D1 also should be sum of row 1. Also D1 should be same into row 2, sum of row 2. D1 also same to row 3. Similarly for D1 will be same to column sum, column 1 sum will be equal to column 2 sum, and D1 will be same to column 3 sum, right? So it actually find out that how many actually such 3 cross 3 matrix are there, which is actually magic square, right? So what is the brute force approach actually I can do actually here? Like I will create all 3 possible 3 cross 3 matrix, okay? Then I will check that this actually this 3 cross 3 matrix is a magic square or not. How can I actually check? I will check by using that iterative approach. That first of all I will check that one condition is if I found out that I have to content the 3 cross 3 matrix content all 1 to 9 numbers, right? There cannot be possible that 1 is present 2 times but 2 is not present, 0. So that matrix should not be a square matrix. First of all I have to check that all 1 to 9 numbers should be present, because in 3 cross 3 matrix maximum 9 element can present 3 cross 3 matrix. So all numbers should be 1 to 9. Okay, first of all I will check that. Then I will find out what is the diagonal sum. There are two diagonal sum, okay? Then I will find out what sum row 1, row 2, row 3, because there will be 3 row, because this is 3 cross 3 matrix. Similarly for there will be 3 column. Then I will find out the 3 column sum. Then I will check all of these are same or not. All of this, if it is same, then only I can actually count this as a square, magic square, right? So just go to actually code, it will be easy to understand. So first of all I will take an answer variable. This actually I have to count number of magic square. Initially it is 0, and I will find out what is the row value and what is the column value. Okay, now I will create all the possible 3 cross 3 square matrix, right? That's why I'm starting from I is equal to 0 and I plus 2 less than r. Means why I have taken this, because suppose this is actually 4 cross 1, 2, 3, 4. So this is actually 4 cross 4 matrix, suppose. So what is the maximum 3 cross 3 matrix are possible? This is actually the bottom most 3 cross 3 matrix are possible, this. So what is the starting row of this? Starting row of this is like this is 0, 1, 2, 3. So starting row is 1. So how many actually row are there? 4 row are there. And what is the starting row? 1. So what actually I can go actually maximum 0. 0 is for this matrix and 1 for 1. How can I getting 1? The left bottommost matrix I am getting by using this, that maximum I can go row number is 4 and I need actually 3 row are there to create a 3 cross 3 matrix. So 4 minus 3, what is the actually value? 1. That's why I can actually go maximum first row, right? Got it? Similarly for column also, here actually column is 0, 1, 2, 3, and so make 4 column are present and I need actually 3 rightmost column at least. So maximum column value can go up to 1. So how can I be getting? I have actually 4 column I need rightmost 3 column, so I can go maximum 1 index. Got it? In this way, that's why I'm actually doing this. Okay, so I will got the starting row and starting column I comma j. So now I will call this helper function. This actually check that this matrix 3 cross matrix magic or not. Okay, if it is magic, then it will return 1, else it is return 0. Okay, if it is 1 mean it is, this will increase the count, else it is 0 means this is not magic square, so I will not increase the count. Okay, and at the end return answer. Got it? So actually I'm going to check that this is magic square magic or not. I'm going to check that I will got the matrix, input matrix, and the starting row and column. I know that this is actually leftmost row column position of the starting cell of the matrix. And first of all, what is the condition? I have to find out all the number from 1 to 9. So that's why I've taken a vector of size 10, where initially it is actually false. Okay, whenever I am seeing any element, I will mark it as true. Got it? Now I have taken a variable d1 for diagonal, one diagonal value sum, and another for d2. This is for d1 and this is for d2. Got it? Initially both are 0, and there are actually 3 row and 3 column are possible. That's why I am taking a row sum, vector of 3 size. Initially it is 0. Similarly for column sum also 3 column are possible, so initially sum is 0. Got it? So first of all I am traversing these 3 matrix. Okay, so that's why I is equal to 0, I less than 3, I plus plus. Similarly for j is equal to 0, j less than 3, j plus plus. So I is equal to 0 and j is equal to 0. That's why I know the starting row R and starting column. So this actually row plus column. Here actually row plus row will be same, column plus 1. This will be row, column plus 2. Got it? So I will increase the j actually. Here actually j is going to increase. That's why I have handled this way, that I plus row and j plus column. Got it? R and C will be constant for the particular 3 cross 3 matrix. Now in this actually I have iterated all the 9 element. Okay, so whenever I am seeing any element, I am mark this as true. Okay, got it? And if it is suppose our for element is this actually mark of this, I have mark which element I have seen in this 3 cross 3 matrix. So I am again traversing 1 to 9. Whenever I am seeing any element which is not is equal to false, means what? This is actually I have not seen in this matrix. So that time I have to return 0, because this is not possible. I have to check all the elements from 1 to 9. All elements should be present at least once, right? So I have seen any element that is not present. That means I can't. I don't have to check the sum is same or not. Okay, that time in this point I can return actually 0. So suppose I have seen all the element 1 to 9. So I will come here in this point. So here actually I will find out the diagonal sum. There are 2 diagonal. So I will try to check the diagonal sum of d1 and d2. So to get the diagonal sum, this diagonal sum, this is actually 0, 0, this is 1, 1, this is 2, 2, right? And this is what? 0, 2, 1, 1, and this is 2, 0. So this is what happening, 2, 1, 0. This is actually decreasing, right? This is actually 2, then 1, then 0. Relation is getting, right? But both row is going to increase, 0, 1, 2. Here also same, 0, 1, 2. So here actually you can check that for this matrix I comma I is equal to same. Here actually what happening, I is going to increase, but j is starting from column, right? So that's why here actually what I'm doing. So I is equal to 0, j less than 2 to handle this diagonal. Okay, I have taken this. I know what is the rightmost column. J is equal to 2 and I less than 3. I can actually go maximum 3 row. That's why I less than 3, I plus plus, and j minus. J minus why? J is equal initially 2, then 1, then 0. Got it? That's why it is going to decrease. So I plus R plus I plus C. This is actually sum of this diagonal. I'm going to access this element of this diagonal, so I'm going to add this into the diagonal 1. Similarly for I plus 1 and j plus 1, here is j means this j. This is going to handle by this in this way. So that's why j plus c will be add to this diagonal 2. Got it? So I'll check, is the both diagonal have to be same sum. If it is d1 not equal to d2, means what? Diagonal sum are not same, so I can return 0. Else what if both diagonals are same? Now I'll find out what is the row sum of all numbers and column sum of all columns. Okay, so that's why I'm going to again traverse the 3 cross 3 matrix. So if I know that grid I comma j, suppose, so here actually what will happen, row is I and column is equal to j, right? This is only point, right? So what I'll do, I will just I plus r will be what is the value of this current index I plus r comma j plus c. I'll add this to the particular row sum of particular index. I know what is the row will be I, ordinate index I will add this. Similarly for I know column sum, j will be the column, at that particular index I will add this value. Okay, now I will get all the row sum and column sum. Okay, now what I'll do, I will just check all the row sum and column sum same or not. So there are 3 row and 3 column are possible, column sum. So that's why I'll check what is that particular index. If it is not equal to d1, similarly for or column sum is not equal to d1, so what will happen? If row sum or column sum, any one of these is not matched with diagonal sum, that time I have to return 0. And if it is matched, all of these matched, that time I will come here and return 1. That this is actually magic square. Got it? So what is time velocity of this? Time velocity of this is that here actually we are traversing each index. So that time velocity will be row close column. Here there are 2 for loop, so r close column. Here also we are traversing each number, so this actually time velocity will be, because 3 cross 3. This is actually constant, actually you can actually assume 3 cross 3. Alright, so time velocity will be, so time velocity will be row close column into 3 cross 3. Got it? This is for the we are finding out what is the starting index of the check square matrix, and this is for to check that this is actually square magic square or not. Got it? And what is the space complexity? Big of 1. We are not using any extra space, or we are not creating any new factor or new matrix. That's why time velocity will be big of 1. Got it?